Scene 1. Could Earth orbit a black hole and survive? Surprisingly, yes. If a black hole has the same mass as our Sun, and Earth orbits it at the same distance, 150 million kilometers, the gravitational pull would be the same. Earth wouldn't spiral in. It would remain in stable orbit. But there would be one critical difference. No light, no warmth, no fusion. Just darkness. Scene 2. Total eclipse. The death of daylight. A black hole doesn't emit light. There's no sunrise, no daylight. The sky becomes a permanent night. Stars might bend and distort behind the black hole's event horizon, forming a glowing halo of lensed light, like a celestial crown. But for Earth, the temperature would drop fast. Without an artificial sun, the planet freezes, just like in segment 10, but even faster. Earth becomes a shadow world. Scene 3. Could we simulate the sun? If humanity foresaw this change, we might prepare. Build orbiting fusion reactors, artificial suns, to warm the surface. Use Dyson swarms to collect background starlight and redirect it. Or construct a planetary shield to trap geothermal energy. It wouldn't be Earth as we know it, but it could be habitable for those who adapt. Scene 4. The view from Earth. Gravity's distortion show. Looking up from Earth's surface, the black hole would appear both terrifying and hypnotic. A perfect sphere of blackness, surrounded by the photon ring, a glowing circle of distorted starlight. Gravitational lensing, light from stars bent around the void. Occasional stellar flares, if the black hole is feeding. The sky would shimmer and swirl in strange patterns. You wouldn't just see the cosmos, you'd see time, twisted. Scene 5. What happens to time near a black hole? Here's where it gets mind-bending. Einstein's theory of relativity tells us, the closer you are to a black hole, the slower time flows. If Earth orbits close enough, time for us could pass slower than for the rest of the galaxy. 1 year on Earth, 100 years for someone farther out. This is called gravitational time dilation. And it's not fiction. It's been measured. Living near a black hole means living in the future, relative to everything else. Scene 6. Could Earth get closer? The habitable zone of a black hole. In 2019, researchers proposed that spinning black holes might emit enough accretion light to warm nearby objects. If Earth orbits just outside the event horizon of a feeding black hole, near what scientists call the Goldilocks zone of a black hole, radiation and light from the accretion disk could mimic sunlight. In this razor-thin orbit, Earth could technically sustain life. But one miscalculation, and Earth falls inward. Game over. Scene 7. Risks. Tidal forces and deadly jets. If Earth ventures too close to a massive or spinning black hole, it would face extreme tidal forces, known as spaghettification. The planet could be stretched, warped, or shredded. Some black holes also emit relativistic jets, beams of radiation that could sterilize entire worlds. Living in this system would mean constant monitoring, constant escape plans, constant fear, a place where gravity is king, and one error is extinction. Scene 8. A civilization beyond time. But if humanity survives, thrives, adapts, we might become something new. A civilization living in deep time, aging slowly, evolving technologically faster than the universe. Our knowledge would leap ahead. While centuries pass for us, millennia pass elsewhere. We could become guardians of knowledge, watching stars let one die while we remain unchanged. Earth, once home to primitive humans, becomes a timeless observatory. Outro. Soft, cosmic music. Earth shone glowing faintly near the dark orb of the black hole. So what if Earth orbited a black hole? It could work, if we're careful, if we adapt, if we redefine what it means to be alive. It would be a colder world, A darker world, but perhaps a smarter one.